Welcome to EELE 261 Introduction to Logic Circuits. My name is Brock LaMeres and I will be your instructor for this course offered during the 2023 summer session by Montana State University. The purpose of this video is to give you an orientation to the course and show you where to access the material that you'll be using. At the end of this video, you'll be ready to engage in the learning activities of this course. All right, so let's get started. This course is the first in a series of courses where you learn about what a computer is. So a computer is a device that operates on information that is stored and manipulated in what we call binary, or ones and zeros. You probably have heard of a computer operating on binary. All a one and a zero is essentially a true or a false or an on or an off, and that's what we call logic, okay? And so a logic circuit is something that only operates on inputs that can take on a true or a false or a one or a zero and output a value that is either a one or a zero or a true and a false. So that's what a logic circuit is. And it turns out that logic circuits are the building blocks of all computer hardware because a computer in itself is a digital device or a logic device. Now, a computer is a collection of hardware and software. And the hardware of a computer is designed to execute a predetermined number of instructions. So these are already built into the computer hardware. We provide what instructions are going to be executed and in a particular order to the computer hardware in order to accomplish a task. And so a computer is a collection of hardware and software where the software is nothing more than the list of instructions to execute and in what order. Now, computer hardware takes many forms. It can be laptops and desktops. It can be servers. It comes in PC and Macs. It comes in, iPhones and Androids, and that's fine. But it's all the same stuff. It's all ones and zeros being acted upon by logic circuits. So in this class, what we do is we start at the very beginning. We start looking at the most basic logic circuits there are, which are called logic gates. And these are simple things like if you invert the input. So if it's a 1, make the output a 0. If the input's a 0, make the output a 1. And we build up more and more complex circuits to the point that we can then take on more advanced classes where we put the circuits together and actually build a computer. But we are in this class looking at the low-level hardware that sits beneath the hood of an actual digital computer. We are not looking at the software that is used to tell the computer what to execute. Okay, so that's what this class is about. It's like I say, you won't know exactly what a computer does at the end of this class, but you'll have the start so that you can take on the follow-on classes that do teach you what a computer actually looks like underneath. Okay, so the topics that we cover in this course to learn about computer hardware consist of 7 modules, and the modules represent an individual chapter in the textbook, but we don't call them a chapter in the course, we call it a module because it's both a chapter in the textbook, an associated set of videos, an associated set of homework assignments, and an associated set of laboratories. So all together we call it a module. And we cover 7 modules or corresponding to the first 7 chapters in the textbook. So we start off with just a really short module, just kind of get used to this notion of what is a digital signal. And we do that by contrasting it to an analog signal, which we might be more familiar with. Then we move into number systems, and we talked about how a computer operates on ones and zeros. So in order to understand how to build circuits that manipulate ones and zeros, we need to understand how you represent information with ones and zeros. And so we learn about how to convert a decimal number into its binary equivalent, and we learn how to do binary addition and binary subtraction, and learn how to represent binary numbers in different codes to represent positive and negative numbers, and in addition to using other number system bases in order to represent large numbers of ones and zeros. Once we get that, we turn to module 3, which is where we actually start looking at the most basic, what we call gates, or the most basic digital logic circuits that we have. And we look at these gates at the circuit level. So we actually realize that even though the inputs and outputs are ones and zeros, they are circuits. They need power, they need ground, these are parts that we can buy from the stock room. We're actually going to put these parts down on a breadboard and we'll wire them up, and we'll look at the inputs and the outputs and see how they operate. Once we have that covered, then we turn to Module 4, which is where we actually start learning how to design what we call combinational logic. So we start taking a description of a circuit and saying, for these combinations of ones and zeros, the output should be ones for these and zeros for those. And then we learn how to actually synthesize or create a logic circuit that can accomplish what we wanted. And we call it combinational logic design because combinational means the output of the circuit is based solely on the instantaneous input of the circuit. Okay, so there's no storage in it. It's essentially a left or right circuit. Then what we do is we move into Module 5, which is where now that we know how to design a logic circuit, we kind of take a different direction and we start learning about a hardware description language. So it turns out that while we learn about how to design logic circuits on pen and paper and we actually can breadboard them and wire them, logic circuits get really big really fast. And so it becomes impractical to be able to model a modern digital system on paper using schematics. So we have invented this thing called a hardware description language, which is a programming language that allows us to describe the functionality of a logic circuit. And that's really cool because we can describe it using text, meaning that we can describe very large systems using just alphanumeric characters. In addition to, since we're describing the functionality on a computer, we can actually perform simulations of the computer or of the description in order to verify that it's accurate. And then once we have an accurate description of what we want, we can run it through another software tool, which is called the synthesizer. And the synthesizer will actually create the logic gate schematic for us. So it'll actually pump out the final schematic that we could then build with our breadboard, or in turn, actually put it onto what we'll learn about is called a programmable logic device. So that's one of the parts that you have in your lab kit. And so this allows us to essentially design logic circuits by typing at a keyboard, which is how you'll do it in industry. But we had to get to Module 5 in order to actually even know what a logic circuit was and then how to actually create something. In Module 6, we get a little bit of practice designing very common combinational logic circuits, which we call MSI logic. It just stands for medium scale logic. It's just medium just means a little bit bigger than a very simple logic circuit. And so we go through a series of learning about various MSI logic circuits, and then we model them in our HDL or our hardware description language, and then we actually implement them or download them onto a programmable logic device and test them. And the V in Module 5, I always say HDL, but the V is a particular language. So it's VHDL. It's one of the two logic description languages that are most common in the world right now. And then we finally wrap up the course with Module 7. And this is on sequential logic. So this sequential logic refers to a circuit that has some elements of storage to it. And so we're not only going to have combinational logic circuits, but we're going to have devices that can store ones and zeros. And what this allows us to do is make a more intelligent circuit because we can base the outputs of the circuit based on current inputs and also past values of inputs. And we culminate the class with this very powerful logic circuit, which is called a finite state machine. And we'll actually build that in hardware. Okay, so before we start looking at the course logistics, let me give you a quick background on myself so you know who I am and who the voice is in all the videos. So, again, my name is Brock LaMeres. I'm a professor of electrical and computer engineering at Montana State University. I've been a professor for 16 years now, and before becoming a professor, I was a hardware design engineer for Hewlett-Packard. At Hewlett-Packard, I designed electronic test equipment, and I was responsible for the digital part of that. So I did logic circuit design using VHDL and the other hardware description language as a practicing engineer before becoming a professor. I got my bachelor's degree from Montana State University back in '98, and then while working for Hewlett-Packard, I went and got my master's degree and PhD from the University of Colorado, which Hewlett-Packard happily paid for. And so I was able to work full-time while I got those degrees. And then back in 2006, an opportunity opened up to come to MSU, and I jumped on it. And so at MSU, what I do is I teach courses in digital logic and what we call embedded systems, which is kind of like a little computer, well, basically computers, but very small computers that are embedded in all sorts of electronic devices. And then on my research side, what I'm looking at is how to exploit reprogrammable hardware in order to build novel circuits. And one of the things that we've discovered is that we can basically use the reprogrammable nature of these programmable logic devices, such as what's in your lab kit, in order to restore a hardware circuit to its original state. And we actually found an application for space computers where we could build this particular architecture, and when you put a computer in space, it crashes because radiation hits it and flips the ones to zeros and zeros to ones. And we found a way that we could build this particular architecture and actually get the computer to automatically recover. So not just reset itself, but actually restore its hardware that could have been faulted. And this got the attention of NASA about 12, 14 years ago, and they started funding demonstrations of this particular computer. And we call the computer RAD PC. And so what I've been doing for many years, and I'll kind of start at the bottom, sorry to make you sick here, is demonstrating this computer on a variety of different flight vehicles. So we've built this thing up and we got approved to NASA that it works. So we've flown it on sounding rockets, which are essentially missiles that just go straight up and straight down. You can see here some pictures of what a sounding rocket might look like. That's about how big it is. It's a missile. Here's me and my team down there in New Mexico. Here's what this computer experiment might look like. It's very small, size of a Rubik's Cube, but you bolt it on there and you fly it and you test how good your computer recovers from radiation strikes. We've done a couple of those sounding rockets. We did another one out of Wallops Flight Facility in addition to New Mexico. Here I am with a student that's showing kind of the size of the second payload that we did. Then we got an opportunity to actually go to the International Space Station in 2017. And so you can see this little box right here. It's floating in the air on the space station about to get installed by an astronaut. And here's kind of the box on our bench right here. And all it's doing is just trying to test the computer in a harsher environment. And then we've had the opportunity to put 2 small satellites into orbit. So they're called small satellites because they're like the size of a loaf of bread. And so you can see this satellite being pushed out of the International Space Station. And these 2 satellites are still actually in orbit right now. We've done balloon flights. So these are high altitude balloons. So this is like the size of a skyscraper style balloon. You can see here's our computer again. Every time we do one of these flights, it's a more mature version of the computer, and we're testing another part of the system that we've made radiation tolerant. And so we've done balloon flights. Here's another satellite getting kicked out of the space station. So it's just been a long career of building and flying these space payloads that are demonstrating this particular computer. And actually right now, like within the last 2 months, we've put 2 more on the International Space Station. And this is what it looks like. You can see here's our little box right here being plugged in on a ground station right there. And there's 2 of these on the International Space Station as I'm speaking right now. And then 2 years ago, we got the big shot. We got an opportunity to go to the surface of the moon. And so we're actually building up this computer, and we're going to go on an unmanned lunar lander, which is scheduled to launch in 2024. And it's actually going to carry this computer to the moon and land, and we're going to get information on how well our computer operates en route to and on the surface of the moon. So as I teach this course, this is not just something that I randomly was assigned. I mean, this is my area of passion, my area of interest. I've done logic circuit design as an engineer for Hewlett Packard. I do research on logic circuits for NASA. I study how to effectively teach logic circuits, and then I practice teaching. I actually am a teacher that has taught this material for 16 years at Montana State University and a couple years at University of Colorado. So now we're ready to actually look at the course logistics. All right, so the course content all begins with a learning management system that we call Brightspace. And the address is ecat.montana.edu. And once you get there, you log in with your net ID and password. So that's what you use for everything. If you're a non-MSU student, you'll get a net ID for this course. And then when you get here, you'll come to the landing page. And what's going to happen is you come over here to My Courses, and you can flick through the semester you're in. We're in the 2023 summer session, and we are the Intro to Logic Circuits class right here. So kind of these blue 1s and 0s scrolling down. So when you come here, there'll be an announcement page. Each week, there'll be some announcements that you'll see pop up here. And then what you can do is go to the content page. So this is where everything is linked. So when you look at a Brightspace, you're going to have all these tools across the top. So you can have quizzes where you can do stuff. You can have assignment folders you can upload to. But everything in this course, I put under content and I link it for you. So when you come in here, if you come into course activities, what you'll see is you'll see these pages, and you see a page for every module. Okay, so we're going to have a course intro, which is like your syllabus. Then we're going to have module 1, 2, 3, up to 7. And then you'll have your final exam that's sitting in there. And then you can just cruise through them. Okay, so let's take a look at the course information and syllabus page really quick, and then we'll look at like what a module looks like. Okay, so you come in here and you're going to see basically some just preliminary information. So you're going to have a course syllabus. Let me go ahead and open that up over there so it's ready. There's a course overview quiz that's part of a graded assignment. And then you got your contact from me, and you got the contact information for our TA, Drew. And so Drew will be, you'll probably get to know Drew pretty well because he's going to help you with everything, and he does all the grading. So when you come down here, this is just information in the same as in the textbook, but it's kind of the highlights with some links. And so the textbook is Introduction to Logic Circuits and Logic Design by me, 2nd edition. And I recommend getting it through Amazon because it's cheaper at Amazon. But to do this class, you need a computer with high-speed internet, obviously, and our design software doesn't work on Macs. So I'm sorry, that's it. If you have a Mac and you can't get access to Windows or Linux, actually, yeah, just Windows or Linux, Windows, you can't do the class. I'm sorry. That's kind of the first lesson of engineering. Get rid of your Mac because all the software tools runs on Windows or Linux now. And so, yeah. So anyway, we're going to install this software on Windows. You're also going to have a digital logic portable kit, a portable lab kit. You should have this right now if you're watching this video. So if you're an MSU student, we emailed you last week and said, please pick this up from Deb in the ECE office. It's a little box, and it's got all the stuff you're going to need, all the circuit components, a little instrument on there to power your circuits and measure them. And if you haven't, email me right away. And you also need a camera capable of short videos. That's how you're going to demo your lab assignments. So you're going to basically just take a video with your phone and upload it. Okay, so let's begin with looking at the syllabus. And the important part of the syllabus is really the schedule. Okay, so you got the course description. We've already gone out that. Outcomes these are the learning outcomes. So when you get done with this class, these are the things you're going to be able to do. It's always funny to introduce learning outcomes at the beginning when half of these words you probably shouldn't understand. That's what we're going to learn. So you should almost do the syllabus at the end. Contact information, blah, blah, blah. What you need. No real prereq for this, just a course in algebra. Let's see, office hours. This is a fully online class. Email is going to be critical. Email right away. We'll set up video calls. We'll try to answer with email, and we'll just see how it goes. So, but remember that there's a live instructor and a live TA. So this isn't just YouTube videos. YouTube videos are one part of it. Okay. Your grading is going to be based on 25% will be homework, 45% will be labs. Labs are where all the learning takes places. And then you have these end of module quizzes that I'll show you about. And then you're going to have one final exam, which is a multiple choice quiz. Grades, just straight grading, 90 and above is an A, 80 and above is a B, etc. All right, academic policies, don't cheat. The difference between cheating and collaborating is where you turn in somebody else's work. That's no good. But if you work with somebody and you guys collaborate and help each other, that's fantastic. That's how the real world works. It doesn't work so much when you turn in your colleagues' work, though. Everybody gets fired. All right, course components. This course is designed so that the reading in the book is exactly what the instructional videos are. I wrote the book first. I actually designed the class first, designed all the material. Then I wrote a book that described it. Then I made all the videos. So these two are identical. And it's just two different modes of delivery. If you're a reader, if you're just like, I just like to read, you can read and everything. You won't miss anything. But if you're like just a person that likes videos instead of reading, the videos are there too. If you want to use them both, awesome. Then you're going to have homework, and homework is going to be due each week, and it'll be in the form of either multiple choice quizzes or simulations that you'll do on logic circuits. And then there's the labs. Labs are really the bread and butter of this course. So this is where you are going to build a circuit on a breadboard. You're going to run it, debug it, make sure it works, and then show that it's working. And then we got end of module quizzes. So that at the end of each quiz, there's a timed multiple choice quiz. And these kind of emulate like mini tests. And the difference between homework and an end of module quiz is that even if it's a multiple choice quiz for homework, you have until the deadline. Okay, so you can open it, work on it, close it, open it, work on it, close it. An end of module quiz is kind of like it's emulating an in-class exam where you have a fixed amount of time. So you start the quiz, You have 30 minutes and then it's over. And if you start the quiz and then log out of Brightspace, it doesn't matter. The clock's running. Okay, so you only got 30 minutes from the time you say go. But these still do have a deadline. You have to complete them by the deadline. All right, here is probably the most important thing of the class. This is the schedule. So let me zoom out and show you this at a glance. So a big old table. Here is the activity you're going to do. Okay. The dates, the week, and how your points are distributed. This is key. All right. So when you look at like week 1, you're going to look at these modules. You got course intro module. There's actually an assignment, right? If you see a point over here, you need to remember that this is actually a graded thing. Now there's 1,000 points in the class. If you scroll down to the bottom, you'll see that there's 1,000 points. So not everything is worth the same amount of points. And that's something to take notice of, because for example, you're going to take a course logistics quiz, right? It's worth 1 point. So that's 0.1% of the class. It's just to get you going, right? Same thing with differences between analog and digital and advantages of digital systems. they're pretty small amount of points, right? However, you're going to have a lab the first week and it's worth 20. So that's like a big thing. And then you're going to have an end of module quiz. And this is just to kind of get you going. Week 1, these activities are due on the first Wednesday of the week. And we have to do that because this class goes quick. We don't have a full semester. We only have 12 weeks. And if you don't have your lab kit and the software installed by the Wednesday of the first week, you fall behind fast, because right by the end of the week, you're going to be working on module 2, which is going to have 4 homeworks, and it's going to have a larger lab that you need your equipment for. And you should have learned kind of how to install everything on lab 1. And then notice that the module 2 quiz is worth a little bit more. Here's the way that deadlines work. The deadlines are always due Wednesday at noon. Okay. Deadline's never on a weekend, never outside of working hours. Okay. So the way the flow works is every week you're working on a module and it's due the following Wednesday at noon. Okay. And the logic there is basically you have the whole week to work on it. You should be able to get it done by Friday at 5. If you don't, you can work on it on the weekend. But if you're working on it on the weekend and you need help, then you have Monday and Tuesday to get help. And so I just kind of picked Wednesday as just a nice point in the week. So if you look at week 2, you're working on module 3, all these activities are due the following Wednesday at noon. Okay. If you look at module 1, or week 1, this is the only one where you have some deliverables that are due the Wednesday of the first week, and you have some that are due the following. So like module 2 is kind of getting into the flow. Module 1 and this course intro is supposed to be, it's really, really easy. It's just to get you engaged, and so that I know you know where the buttons are to click and get help on this stuff. It's like the quiz, I don't understand the quiz. Where's the submit button? Those are the type of things. The software didn't install, blah, blah, all that stuff. Okay. So then you walk through this, and the way to kind of read this is that you've got homework points, and then you've got lab points, and you've got a quiz point, and they need to be done by the following Wednesday. But notice how as you go through the semester, the points start increasing. And that's to reflect that the complexity does increase, and you can kind of tell the type of assignment you're going to have, right? So you're going to have some that are just like facts and figures, like what is this name, etc. And you have some that are going to be like, oh, synthesize a circuit, and you're going to get a few more points than that, then because it takes more effort. So the points do reflect kind of how much time it is. So look at the week look at this table each week and kind of figure out like, okay, I see in week 6 we're going to have 5 homework assignments, right? But the first 4 are like worth hardly anything, and then 5th one is worth a monster, and it's even got 2 asterisks. That means you better make sure you save some time to do that thing, okay? All right, and then we just lather, rinse, repeat throughout the entire thing. And the ones with asterisks, they really mean that they're a simulation. So you're not going to be doing a multiple choice quiz. You're actually going to be designing a circuit in using a language and then simulating it and making sure the ones and zeros are correct, all right? And then we do have a final exam. So when you get to the end, you basically, your last week, week 11 will be due Wednesday the following week, of course. And then this little fella right here is just going to be due Friday at noon. So that's another one. That's the only deadline that's not on a Wednesday, okay? So that's the syllabus. Let's take a look at what a normal module looks like. So I'm going to click this arrow to go to module 1. Module 1 is not, I wouldn't call it it's got the flow of a normal module, but here's what it looks like. You always got a Module 1, learning outcomes, what you're going to learn in this thing. Then you have these sections, and each section is a section in the book. It's got some videos, and it's got some sort of homework assignment, okay? So in this situation, if I click on that, I get a video. I click on that, I go to a quiz, etc., etc. You go to the lab, you get a lab description, you get an overview video, and you get an assignment folder. And then you come down here and you take the quiz. Everything's linked right here. So I designed this so that you don't have to be trying to search through all the tools at the top to find stuff. It's like you can get to all these things with the tools at the top, but you don't have to. I link everything in here. So where you want to be is the module pages. So let me go, I want to go to like a normal module really quick and just show you like what it is. They're all normal. Actually, module 1's really it's short, okay? So here's like a normal module. You got all these videos and you're like, man, what is with this? A lot of stuff in here. And so let me open this lab description and let that load for a second because it's a big document. Overview video, right? So on some of the labs, I give videos. And then if I look at like the lab handout, which is going to load, oh boy, which is going to load there for a second. Let's see where it's loading. It's on its way. It's on its way. The lab handout or handbook is one giant PDF. So you download it one time and you don't have to do it again. Okay, so that's why it's taking so long. So this has all the lab assignments in it. So I'm going to scroll down a little bit. Sorry for the car sickness. It shows you all the parts in your kit. I want to get down to like a lab. Oh my gosh, sorry to make you sick. So here's like a representative logic lab. You're going to have like a description of what your circuit is. You're going to build it on a breadboard. So you get all these little pieces in your lab kit and you're going to put them on there and you're going to use this instrument that provides power to your breadboard. Okay, so it's going to look kind of like this and it's like, oh man, and you build all this stuff and you tell if it's working with LEDs and you put inputs using switches. And I want to show you the analog discovery really quick. Might want to shut your eyes before you vomit here. Oh. I'm getting sick. Hang on. I promise. Okay, here's, oh my gosh. Let me go to lab. Here it is right here. Okay, so this is your analog discovery. This is in your lab kit. This will provide power to your breadboard. It'll drive in logic signals. You can look at logic signals. And this is kind of the instrument that you'll use to make it possible that you can do a lab remotely. Because if you didn't have this, you'd have to come into the lab on campus. Okay, let's look at a traditional like video. Okay, so let me look at this one right here. Now these are YouTube videos, and so let me mute that so I don't talk over myself. And there's some ads in here, you know. Don't worry about it. let a ad play, I guess. Why won't this one go away? Oh man, this is a 15-seconder. Yay. Don't worry. The ad revenue is not as much as you might believe. Okay, so here's like a typical video, right? So here's me. I'm like, hey, here it is. And I'm sitting there writing. I'm just writing on a piece of paper. So this is kind of like you're sitting in a classroom watching somebody write on a board, except it's me. And you can stop it and you can speed it up and you can slow it down. And so this is kind of this is what these classes are going to look like. You're going to sit here and watch videos, then you're going to do the homework and off you go. All right, so let me stop that. Let me show you, I want to show you two types of quizzes. So we've talked about the labs. I want to show you like one of the quizzes. So let me look at homework 3.3. So here's a homework and let me like preview it so you can see what this looks like. So I've come in here. My shell looks just a tiny bit different than your guys's because I'm the instructor. But here's like an example. Provide the transistor level schematic for a 4-input NAND gate. You shouldn't even know what this stuff is yet. But you look at these schematics and you're like, yeah, that might be it. I don't know. It might be that one. So whatever, go for it. And then you do this one and then you do that one. And then you're like, there's only 3 questions on it. So I submit my quiz. And it says, you didn't answer some of them. And I say, yeah, go ahead and submit. And then it comes back and it says, man, you missed. And it gives you your score immediately. Okay, so I got a 0 out of 3 on that one. Okay, no good. All right, as we get going, we're going to wrap this up here really quick, but I just want to show you one last thing. Once you get down to like module 5, we start using a tool, and the homeworks will kind of change into stuff like this, where you click on this link and it's no longer a quiz. It's actually an assignment that shows you like a simulation. So you're going to be sitting here going, okay, I'm going to design this, and these figures will be live. Actually, they are live. So this kind of shows you what your output will look like right here. And that's what the output of the tools look like. And then you have like, it just describes everything that you need to do. Okay, so that's like the difference between them. Okay, I believe that that is it. Okay, so at this moment in time, you should have your lab kit, or if not, email and we'll get going on that. And you should be able to start working through the content. So the first thing you should do after watching this video, you got the syllabus, look at the table, get your bearings, and then start cranking away on module 1, because it's got deliverables due this week. And then there's also this course activities, course overview. So on the syllabus, you're going to have this course overview quiz, which is right there, and it's due on Wednesday. And you're going to do that, and it's just going to ask you questions about like the course content, like when are deadlines due and stuff like that. Okay, I look forward to working with you, and we will see you shortly.